All right. Chapter 1, Section 3. Chemical and physical properties of matter. This should be a fairly short video, so let's get right into it. Okay, physical properties are what we're going to be starting with. A physical property is any property of a material that you can measure without changing the substance. Okay, I realized I didn't necessarily explain this last time. A W with a slash means with. So W slash out means without. Similarly, I have B slash in for between. All right, so you can measure a physical property without changing the substance. So for example, if you have solid water, that is to say ice, you can change it to liquid water, that is to say water. And when you do so, that allows you to measure the melting point, okay? The temperature at which water melts. You have changed the water, but it's a physical change, not a chemical change. Okay? So you still have the same substance, H2O, before and after. So all physical properties are like that. They deal with the substance as a substance. So examples of physical properties would be things like the melting point or the boiling point, phase change temperatures. Density is a physical property of the substance. That's how much matter there is per unit volume, how much matter you pack into how much space. Let's see, what else would be color is a physical property. Just size, or I should say volume and mass would both be physical properties. Let's see, vapor pressure. If you have a liquid, it will exert some pressure. That's why liquids evaporate. So vapor pressure is a physical property. As is, just the temperature of the substance is a physical property. So there are lots and lots of physical properties, is what I'm trying to get at here. Okay, so let's keep going with physical properties before we get into chemical properties. They can be divided into two kinds. There are extensive and intensive physical properties. Okay. So this is a distinction that can sometimes be a little bit confusing. An extensive property depends on quantity of substance. Okay. So it depends on how much of the thing you have. Okay. So the more of something you have, the less of something you have, that's going to change the property in question. Okay. So for example, mass is an extensive property. If you have more of something, you're going to have more mass. Similarly, volume is also going to be an extensive property. Now, by contrast, an intensive property does not depend on quantity. Okay? So it's independent of how much stuff you have. So, for example, temperature is going to be independent of the amount of material you have. Color is going to be independent. Density. Density is the ratio. Okay, so you take the ratio of mass divided by volume, that gives you density. And ratios of extensive property are always intensive. Okay, so the relationship between two extensive properties is going to be an intensive property. Let's see. Also, boiling point and melting point are also intensive properties. So one way to think about this is if you add two chunks of the substance together, is it going to change the property? Okay. Yes, it changes, then it's an extensive property. So you have two things, you add them together, they're going to get heavier. You're going to have a total heavier thing. Mass is an extensive property. Similarly, two small things make one bigger thing. Volume is an extensive property. But if no change, makes it an intensive property. You know, you have two things, they're both blue, you put them together, they're still blue. Okay, that's an intensive property. Two things, they're both at room temperature, you put them one on top of the other, they're still going to be at room temperature. Temperature is an intensive property. You know, density, boiling point, melting point. Those are all intensive properties. Next up, we have our chemical properties. Chemical property deals with change in substance. Okay, or I should say change from substance to another substance. Okay. So it could be, two elements coming together to form a compound breaking apart to form, different things. So for example, you have hydrogen plus oxygen making water. Okay, this is a chemical reaction. This is a chemical change. Hydrogen and oxygen have the chemical properties that they react with one another to form water. In the same way, calcium carbonate, limestone, if you subject it to heat, then it will decompose and form calcium oxide and CO2. Okay? That is a chemical change. It's a chemical property of calcium carbonate that you can break it down in that way. In a similar fashion, sodium plus liquid water, okay, so let's go ahead and say solid sodium plus liquid water, will react to produce sodium hydroxide and hydrogen gas. Iron, solid iron, will not react with liquid water. Okay, liquid water gets no reaction. In R, no reaction. But if you add iron to steam, gaseous water, you will get a reaction. You'll get iron hydroxide and hydrogen gas. By contrast, going even further down this sort of scale, gold will never react with water. Solid, liquid, gas, doesn't matter. Gold just doesn't react. Ever. Okay? These are all examples of chemical properties. They deal with the change of substance into another substance. You cannot measure a chemical property without causing a change in substance. So, cannot measure without changing substance. Another way to look at this is that physical properties deal with physical changes within a substance without changing to a new substance. Chemical properties deal with one substance changing to another substance. And that is all I personally have to say about that. See you in the next lecture.